sizes and the names or the codes which they are provided, like in this case 18650. 18650 defines its dimension. So in here 18 would be the diameter, its unit will be mm, and the 650 would be its length. But don't consider zero at the end. The length would be 65 mm. The zero is just for naming case. In this cases, in the image on the right side, you can see that Panasonic writes the, like they use the terms 1865 and 2170 and 4680.
So can you tell again dimension?
Okay, yeah. So the dimension cell is clear, right?
Yes, sir.
Okay, good. So in this case, in cylindrical cell case, first two digits would define its diameter. So in this cell, 18 mm diameter is the first two digits of the nomenclature, and 650 would define its length. But in this case, don't consider the last zero because the length would be just 65 mm. Or height, you can say height. So this height would be 65 mm and the diameter would be 18 mm. In the other case, 2170 or 21700 cells, the diameter would be 21 mm and the height would be 70 mm. And lastly, we also have 4680, in which 46 is its diameter and 80 would be its height. So basically, all of these types of cells are being used by Tesla in each and every model of their cars. So their Model 3 would use 21700, but their Model S would be using 18650. And their last Model Y, which or the one which was recently launched, they are using 4680 in that particular model. So there are reasons for purchasing cylindrical cells. One, because they can be easily housed into battery modules. Like producing a battery module, like in one battery module, there will be number of cells, almost 150 to 200 cells. And in an entire battery pack, there will be around 7,000 cells, depending on how much capacity is required. And it changes. The number of battery cells changes from car to car based on its what we call genre, like based on its concept or whatever category it is being like it is going to run in. So the average capacity of an 18650 cell is 3.9 Ah ampere hour. And when we compare it with the 21700 cell, then its average capacity is 6 Ah. So just to compare the 18650 with 21700 cells, the volume of 18650 would be 16 centimeter cube, while that of 21700 would be 24 centimeter cube. So the volume is not increased by a factor of 2, but the capacity of a 21700 cell is more than that of an 18650 cell. And that's why many manufacturers are using 21700 cells for their EVs. We are going to talk about each of those battery packs as well. So one of that factor is like why 21700 is so preferable is this, because it can carry more energy. It can carry more capacity for its volume compared to 18650. And at this point, majority manufacturers are using Panasonic and Samsung cells. India is coming up with battery manufacturers, and we all are aware about how many lithium resources we have found across India, and that's why there are plenty of manufacturers for lithium. Recently, or almost 1 year ago, Tata has announced their battery manufacturing plant in Dholera, Gujarat. So that would be one of the biggest lithium-ion battery facility of India. So that's one of the reasons why cylindrical cells are highly preferable. Now let's move to various types of battery chemistries. So I had to include lead acid battery in this because manufacturers have been using lead acid battery for a long time now. And these types of battery are used for basically cranking the engine in our ICEVs. And simultaneously, these type of battery will also provide some energy to the auxiliary systems like our infotainment system, our air conditioning system, when the engine is not turned on, and even our this side indicators and headlight, tail light, and telltale light of the dashboard. So basically, lead acid battery pack uses two electrodes, the positive and the negative electrode. I'm not going to name them as or term them as anode and cathode because the terms anode and cathode changes based on how the battery is being used. So yeah, is there a doubt or is there are you sharing something? Okay. So yeah, I'm not going to use the terms anode and cathode over here because when we are charging the battery pack, the anode the anode would become a cathode, while the cathode would become anode. So that's why, not to confuse you guys with those terms, I'm going to use positive electrode and negative electrode. And in this case, the positive electrode is made of lead peroxide, and the negative electrode is made of spongy lead. That means just PB, just the lead. And the electrolyte is dilute sulfuric acid, which is H2SO4. And to dilute it, we use distilled water. So in this case, the dilute sulfuric acid would react with lead of both the electrodes, and they will have ionic exchange between each other. Of course, there will be a separator in between both the plates, because we don't want internal short circuit happening. So the electron, as the lead would react with SO4 minus, the part of H2SO4, it would give away electrons, and that electron will travel through an outside circuit, while chemical reactions would happen between the positive and the negative electrodes, and there will be sulfation of PbSO4 happening on each plate. So as the cell gets, or as the battery pack gets discharged, you can see that PbSO4 would be it would be on the positive and the negative electrode, and that's the worst case of lead acid battery. So we try not to go at that point, because at that point the battery would become dead. So that's how lead acid battery works. The separator it prevents the electrons from traveling through the electrolyte, because we don't want internal short circuit to happen. Now, there are basically two types of batteries in lead acid battery, which is VRLA and AGM. VRLA stands for valve regulated lead acid battery, while AGM stands for augmented glass membrane type or gel type battery. So VRLA are most commonly used in our ICEVs. Even in your car, if you open the hood of your car and just check the battery, and you will see 6 screws on top of it, or else there will be 2 blocks covering something. So that's actually a valve. You can access each and every cell of the battery pack of lead acid battery. And in our lead acid battery, in our bikes and in our cars, we use a 12-volt battery. Each 12-volt battery will have 6 cells, and that each cell would have 7 to 11 plates. Okay? So we are not going to go further deep into lead acid battery, because so let's move on to those portions as well. Okay. So the next type of battery we have is the nickel cadmium battery. Now these were previously used in our old cell phones, and they are not highly preferred for our electric vehicles because of cadmium. And cadmium is actually hazardous for human health. It can have adverse effects on our physiology. That means it can almost temper with our DNA, and that's why cadmium is not usually, or it is not at all preferable for EVs. But as it was used in our cell phones previously, so that's why I'm covering this. So nickel cadmium battery will have nickel oxide hydroxide as its positive electrode, while cadmium as its negative electrode, and potassium hydroxide would be its electrolyte. So usually this type of battery cell is housed in a cylindrical form, and the approximate voltage for this type of battery is just 1.2 volts per cell. In case of a lead acid battery, it would be around 2 to 2.4 volts per cell. But in case of nickel cadmium battery, it is quite lower than a lead acid battery, and that was the second reason why it is not preferable for electric vehicles, or even simply our vehicles as well. The third reason was nickel cadmium batteries tend to have memory effect. So if you remember, like in old days when we were using those old Nokia phones, they had nickel cadmium batteries, and the dealer would usually suggest us or advise us to charge the battery to 100% and discharge it till 0% for whenever we purchase a new phone. So there was a reason, because you don't want nickel cadmium batteries to get into that memory effect charging discharging cycle, because at that point the battery's lifespan would decrease tremendously. So the next one, which is the most popular one, the lead acid battery.
Excuse me.
Yeah.
Your screen is not visible.
The PPT is not visible.
Yes, yes.
How is it possible? Because okay,
Somebody changed the screen sharing option, I think.
No worries, I will
it's visible. In fact, it is visible to us.
Yes, it is visible.
Okay.
No,
Can
sir,
you,
we didn't visible the PPT.
can you share it once again, sir?
Yeah, I'm sharing.
Visible is it?
Yes, now it is visible.
Now it is visible.
Dhire
Now it
dhire
is
balma.
visible.
Oh, oh,
Sir, please, someone mic is mute, sir. Not showing, sir. Please, someone is mic switch off.
Wale chalo mo.
Okay, is my mic muted? No.
His mic is showing sing song actually.
Yeah.
So please,
I heard that.
only lecturing will remaining will please switch off the mic, sir.
Yes.
Please.
So yeah, the most famous one which is used in our electric vehicles, that is the lithium-ion battery, and there are multiple anode and cathode, there are multiple battery chemistries in just lithium-ion battery, and those chemistries are based on their anode material. So basically, you guys would have heard of terms LMO or LFP or NMC or NCA. So these are the materials which are used for anode. So either it will be the anode material would either be lithium cobalt oxide or lithium manganese oxide or lithium iron phosphate or nickel manganese cobalt oxide or else nickel cobalt aluminum oxide. Now there is another battery chemistry in lithium as well, which is the titanate oxide, and that in this particular chemistry, the lithium titanate oxide would be used as a cathode, not as an anode. But in all of these chemistries, these are the chemicals which would be used for anode material. And these anode material, we don't use a solid anode plate for these made of these material. We usually coat these material on sheet of yes.
Sir, I have one doubt.
Yeah.
Yeah, so the anode material is positive terminal or negative?
Yeah, that's why. See, in cases of anode is the one which gives away electrons. That means it is the negative terminal. It is the negative electrode.
So, I think so. This is wrong. Cathode material is a positive terminal and anode is negative.
Yeah, I have mentioned this in the previous slide of when I was talking about lithium-ion battery, lead acid battery. So the terms anode and cathode would change. When we are charging the battery pack, the positive terminal is now the cathode.
Yes,
okay.
Sir.
That's how it changes, and that's why I mentioned this earlier. In this case, it was easy for me to mention anode and cathode because the materials are specific for anode and cathode in this case. Okay, if you search, there are two types of actually battery, electrolysis chemistry. When we are using the battery as an electric source, then of course the anode would be the positive terminal and the negative terminal, and the cathode would be the positive terminal. But when it comes to charging the battery pack, we are actually planting the lithium ions in the negative electrode, in the graphite. So that time the cathode would be the negative electrode and anode would be considered as the positive electrode.
Okay.
Yeah. Okay. So yes. So this is one of the most highly preferable battery chemistry, and the reason being it can carry its battery capacity is quite high. Only one single cell can provide 3.6 Ah and about 2 to 2.4 volts, at times 3 volts as well. And that's why this is highly preferred, and its size is pretty small. You can see, as I talked earlier in the cylindrical cell, the 18650 cell can provide 3.9 Ah. So that is quite high. Is it for everyone or is it for just you? I'm sorry.
It's visible, sir.
Okay.
Visible, sir.
It's visible, sir.
Okay.
Visible.
Ma'am, there might be a possibility that you might have pinned someone else on your device, and that's why you might not be able to see my screen. That can be a case. Please check that.
No, now it is visible, sir. No issue.
Okay.
Sir, I have another doubt. In which case oxidation reaction will be taking place, and in which case the reduction reaction will be taking place in case of anode and cathode?
Okay. So basically, in reduction, during discharging, the redox reaction would be happening, and during I need to confirm this because my chemistry side is not that strong. Okay.
Sir, let me show you one thing.
Yeah.
Generally, cathode is considered to be a positive terminal.
Yeah.
And the anode is considered as a negative terminal in a battery.
Yeah.
So most preferably, the anode materials that has been using in the lithium-ion batteries are graphite or LTO, and it may be some of the carbon-based material or graphene that maybe they are using.
Exactly.
Where in case of cathode, they are using all those things, LOC, LNMO, or NMC. All these
Yes.
things are they are using for the cathode material.
Yes, yes.
So initially, in the anode only, the oxidation reaction will be taking place, where it will be the loss of electron,
Yes.
and the electrons will be transferring to the external circuit, and the lithium ions that will be like intercalated or substituted in the cathode position.
Yes.
So I think so. There is some changes. Like it is
Yeah.
something.
I totally agree with you, because as I said, like even I get confused when it comes to anode and cathode, because what is a negative terminal, what is a positive terminal or
So
electrode?
there are two types of systems that are there in chemistry. One is There are two types of cell. Like one is galvanometric cell, and we have report Daniel cells, all those things.
Yes.
So in case of galvanometric cells, your case may be right. Okay, they will be considering cathode as a negative as well as anode as a positive.
Yes.
But in the case of lithium-ion batteries, it is necessary to consider anode as a negative and cathode as a positive.
Yes. So thank you
Okay.
for clearing that out.
Sir, and also to make it more simple,
Yeah.
the electron flow is always from negative to positive as shown
Yes.
in diagram.
Yes.
So then we can confirm that anode is negative.
Yes. So
Sir,
yeah.
what I feel is first you complete your content and then we'll have a 10 minutes this question answering session. It is disturbing.
Okay. So lithium-ion battery has been it has been shorted by one of you guys. Thank you for that. So moving ahead to the thermal runaway in lithium-ion batteries, as I said, there are three basic reasons why thermal runaway can occur, and basically those three reasons will end up into one single reason, which is internal short circuit. So as I mentioned earlier, which is one of this is mechanical abuse. So whenever an outside force is applied on the the casing of the battery cell, and if it punctures the battery cell, then there are chances that the anode and the cathode material will connect or come in contact to each other, because there is barely any gap between them. There is micrometer gap in between each and every anode, cathode, and separator. So because of such mechanical abuses, the internal short circuit can occur, and that will lead to tremendous it will lead into heat generation tremendously fast, and at the end it will end up into fire. Simultaneously, we have second reason, which is the electrical abuse. In electrical abuse, of course, overcharging and over discharging a lithium-ion battery can again result into formation of dendrite, and dendrite formation would be dendrite for yeah. Okay, so it will lead into dendrite formation, and dendrite formation would rupture the separator, and it would short circuit with the anode and cathode material. So that can lead into tremendous heat generation and fire. And lastly, we have the thermal abuse, in which externally heat can increase the temperature of the battery cell, and it can rupture the separator and lead into internal short circuit and thermal runaway. And that's why thermal runaway is focused more on lithium-ion batteries, because they are highly prone to catching fire, and simultaneously lithium is highly reactive in nature, because when it comes in contact with water, it will produce hydrogen, and hydrogen is flammable in nature. And if lithium-ion battery is already under the thermal runaway procedure, and if you pour water on top of it, the fire will catch, and there are chances that the battery pack would burst. And that's why this needs to be pointed out. And majorly, it is controlled using BMS and our cooling methods. So that's the thermal runaway in lithium-ion battery. So moving ahead, we have the nickel metal hydride battery. And in this case, again, the positive electrode is made of nickel hydroxide, and the negative electrode is made of hydrogen absorbing metal. So metal hydride, in the sense, in this case, we can use metal or copper or any material which can absorb hydrogen. And the electrolyte would be same as nickel cadmium battery, which is potassium hydroxide. And because the negative electrode composition or the chemistry which we are changing over here, the capacity of this type of battery increases by 2 to 3 times compared to nickel cadmium battery. But it is slightly less than lithium-ion battery. So this type of cell or this type of battery chemistry is being used by Toyota and Lexus, although both Toyota and Lexus are daughter and parent companies, and they are using these cells for their Toyota Camry hybrid and Lexus LS 300H. So we then have the metal air batteries, and in metal air we can have multiple anode. Like there are options of using any anode out of these names. So lithium, sodium, potassium, zinc, magnesium, calcium, aluminum, and iron can be preferred in this type of cells. And the positive electrode would of course be air, but the electrolyte would be potassium hydroxide or lithium hydroxide or any sodium hydroxide in aqueous form, which means it would be diluted. And the capacities of each of these cells based on the chemistry, you can see lithium has the most highest capacity compared to other chemistries. And although lithium is already being used in the form of lithium-ion batteries, and that's why we are not going for lithium air batteries at this point. But if we are speaking in terms of battery swapping methods, then these batteries are highly preferable because it is easy to change the negative electrode, and in majority of these cases the negative electrode, which means the metals are going to be eroded in these battery cells, so they will need to be replaced when it comes to recharging this type of battery cells. So moving ahead, we have the sodium sulfur battery, and sodium sulfur batteries uses liquid sodium and liquid sulfur. Now as I'm saying that they are using liquid sodium, which means its temperature is going to be high, about 300 to 350 degrees Celsius. And the sulfur will be housed in carbon sponge. So the sodium will react with beta alumina and then the sulfur, and it will create N2SO4. And simultaneously, the sodium will give away electron, which will travel through an outside circuit. So these type of cells are currently under research, and recently in 2020, delegates or researchers of IIT Madras were working on this type of batteries. Their battery cell chemistry was sodium sulfide battery, and they had made their cell to have zero self-discharge rate. So that was quite a achievement for them, and that's why I've added them in this presentation. So those were all the types of battery chemistries. Recently, aluminum-ion battery chemistry has come to surface, and similar to lithium-ion battery cells, aluminum-ion would use aluminum as its one of its electrode, and graphene as another electrode. And the pro of using aluminum is that it can provide more electrons compared to lithium. So it can almost provide 3 electrons per ion, and that's why it can be the future of electric battery cells. So at this point, aluminum-ion battery cells are currently under research, and that's why its theoretical voltage value is about 2.5 to 2.6 volts, and its theoretical energy density is almost 1060 watt-hour per kg. Watt-hour, that means 1.06 kilowatt-hour per kg. That's a theoretical value right now. So those are all the battery chemistries, and let's move to battery management system, because as I said, that thermal runaway is one of the biggest issue of lithium-ion batteries, and one of the way to prevent thermal runaway in lithium-ion batteries is by using battery management system. So the focus of battery management system is to monitor voltage, current, and temperature of the cells. Simultaneously, while monitoring each of these parameters, it protects it from overcharging, over-discharging, short-circuiting, and thermal runaway. So basically, whenever the BMS would sense high voltage or high current surge, it will cut off that particular cell from the battery, from the entire system, and that's how it will prevent it from thermal runaway. And lastly, it will also look after cell balancing, which would either be passive cell balancing or active cell balancing. So this particular BMS that I've shown in this image is for just 4 battery cells, and it can monitor the voltage, current, and temperature of each of those cells. In majority cases, when it comes to our vehicles, we have almost 5,000 to 7,000 cells in each battery pack. I'm sorry, the entire battery pack. So it cannot monitor each and every cell individually. So they have different protocols for it. So let's first understand how cell balancing occurs. So basically there are 2 types. One is passive cell balancing and other is active cell balancing. So in passive cell balancing, when a BMS... Okay, please can you turn off your mic? Yeah, thank you. So in passive cell balancing, whenever the BMS would whenever the BMS would come to know about if one cell, the voltage of one particular cell is decreasing pretty fast compared to other cells, then it will cut off that particular cell from the entire battery pack, or else it will simultaneously activate the resistance across other cells so that they deplete the voltage quickly, so that each and every cell would come to a same voltage level. And this is one of the most easiest method to balance the lithium-ion cells when it comes to BMS algorithms. But what manufacturers prefer is the active cell balancing, in which when the BMF comes to know if one cell is being depleting fast, quickly, then it will connect other cells together with that cell, and it will provide electricity from other cells to charge the one that is depleting fast, and it will bring the voltage level of each and every cell to same point and or the same voltage output, and that's how it will balance each and every cell in active cell balancing. So basically, the algorithm for active cell balancing is slightly complicated compared to passive cell balancing, but as it is the most preferable way, so that's why active cell balancing is highly preferred. And as I mentioned earlier, that there are numerous cells used in one battery. Someone's mic is on, and so yeah. So as I said, there are almost 4,000 to 7,000 cells used in a battery pack. And so there are almost 4,000 to 7,000 cells used in a battery pack. So monitoring each and every cell with one BMS can be quite tricky. Not just quite, it will be tricky, definitely. And that's why we use BMS communication protocols, in which we will have this master and slave configuration. So the cells would be divided into multiple modules. So as I was saying, there are almost 4,000 to 7,000 cells used in a battery pack. But those 4,000 to 7,000 cells would be divided into 7 to 8 battery modules, and each battery module would have 100 to 200 cells in them. And those 100 to 200 cells would be monitored by slave BMSs, while the master BMS would be in communication with the slave BMS. So this master BMS and slave BMS will use CAN bus protocol. So CAN bus protocol is being highly implemented in our cars from more than a decade now. And it is majorly used for communication between ECU and the sensors of engine, and simultaneously of in body control unit. So up till now, CAN bus protocol is again implemented in BMSs as well, because its redundancy is quite better compared to other protocols. And we also use lean bus protocol and D2B and Flex series, but CAN bus is highly preferable in this situation. So I'm not going to go deep into the how CAN bus protocol occurs and what kind of messages it is being transmitted, but it uses two wires, which is CAN high wire and the CAN low wire. So basically, the reason why two wires is being used is this, that if one wire, if let's say CAN low wire is ruptured or it is damaged, then the messages would still be transmitted through the CAN high wire, and that's why it has high redundancy, and that's why it is highly preferred in EVs as well for communication between BMSs and the master BMS. So moving ahead to our battery cooling system. Now we basically have three cooling methods. One is air cooling system, the liquid cooling, and the PCM method. So in air-cooled method, again, as I mentioned earlier, that Toyota Prius used prismatic cell, and basically they were air-cooled. So they had a separate air blower that would suck the air from environment, and it will push it, or it will forcefully push it through the battery cells, and it will cool down the battery pack. And similar such method can be used in the EVs, but no one prefers air cooling system for electric four-wheelers. But when it comes to two-wheelers, of course, we are using air cooling system, because we don't have that much space to house a blower or other systems in that small space. And in our two-wheelers, we use natural convection. Basically, whatever air would flow through the front whenever the two-wheeler is being driven, that air would cool down the battery cells. And that's how this type of cooling system occurs. But the issue with this type of cooling system is that it is not as efficient as liquid cooling system. So when it comes to liquid cooling system, there are basically two methods of cooling. One is this, which is flowing the coolant through channels. The other one is immersing the entire battery cells, each and every cell, in a liquid. in a cooling medium. But this second method of immersing the cells into a cooling medium is not preferable because the cooling medium or the liquid that we are using, it must be dielectric in nature. It must be insulating. It should not conduct electricity because if that particular liquid is conducting electricity, then the battery cells can short circuit because of it, and it can again lead into thermal runaway. And that's why that particular method is not preferred. And basically, we use something like this. We have channels for the liquid to flow in, and the liquid which we are using in this case is ethyl glycol and water. It is a mixture of ethyl glycol and water. It is the same sort of solution which we are currently using in our ICEVs for cooling the internal combustion engine. So as cylindrical cells are being used, the surface area for cylindrical cell is like highly preferable for cooling it with the help of this method. And there is another method in which the bottom plate cooling method is used. So in that case, the cooling channels would be provided at the bottom of the cell module, and it will absorb the heat from above it, and it will give away through the heat exchangers. So this is the type of bottom, like this is an example of bottom plate liquid cooling system, where the channels are provided at the bottom, and they would it would absorb the heat from top above it. And the last one is phase change material method, in which case phase changing material, everyone would be aware about wax and paraffin wax. So yeah, those are kind of those are the preferred PCM materials used for this cooling method. And in that case, the wax would absorb the heat of cells, and it would change its phase, and it would give away the heat, and it would again change its phase to solid medium. So PCM method is not used at this point, but it is being still worked on to use it in our vehicles because it has some good potential. But at this point, majority four-wheeler manufacturers are using liquid cooling method, and two-wheeler manufacturers are using air cooling method. So now let's look into battery packs of various manufacturers, starting with Aether's battery pack. And you can see in Aether's battery pack, they only use a single battery module, and the cells are being housed within the casing, which is made of aluminum. Simultaneously, they are only using a single BMS because the number of cells are easy to handle with just one BMS. So in this case, you can see the battery pack is being housed in the bottom end of the chassis. I guess my screen has been, is my screen still visible, right?
Not visible.
Yeah, I thought
Not
it was
visible.
Yeah, the dialog box at the corner was gone, so that's why I just confirmed it. Thank you. So yeah, the battery pack is housed at the bottom of the chassis, and the cooling channels have been provided at the front end so that the air can flow from the front whenever the two-wheeler is being ridden, and that's how they keep the battery temperatures low in this case. Similarly, we have Ola's battery pack. Now, Ola is using 21700 cells, and they are using the space quite efficiently in their two-wheeler, and they have housed the cells in such form, and they connect the structure which is used for keeping the cells in its place is being designed pretty well. And again, because of this type of structure, the air can flow from the front, and it can cool the cells easily. Then I had to focus on Tesla's battery pack as well, because as I said earlier that this type of battery pack definitely uses liquid cooling system, and you can see these are the channels of liquid cooling system, and simultaneously this blue material is actually foam. So the reason they are using foam in this in their modules or in their battery packs is that it provides a cushion whenever the car is being impacted from side, because in our cars they are the battery packs are prone to side impact, then they are prone to front or rear impact. And to prevent the mechanical abuse of the battery cells, they are they use foams. They actually they spread the foam over the battery cells, and the foam actually hardens up. So in this case, the foam is quite rigid, and it prevents the force to be impacted on the cells. The second type of battery pack that I want to talk about is Rivian's R1T battery pack. So in this case, they are housing the battery cells on top of each other. The one battery module would be at the bottom while the other would be on the top. and they are using the bottom plate cooling method in this case. So this is the cooling plate. And similar to Tesla, they are also using this yellow colored this foam. But compared to Tesla, where like there have been experiments where the foam of this particular battery pack, the Rivian's battery pack and the Tesla's battery pack, they took out the foam out of each of their battery pack and they deliberately burnt those foam. So Tesla's foam, this one would catch fire and it will the fire would prolong for quite some time unless and until it is being extinguished by an external method. So that was one of the issues with Tesla's foam, because if the battery cell starts, if one of the cells goes to thermal runaway and it catches fire, there are chances that this foam will actually spread that fire through the entire battery module, and it can lead into a disastrous condition. But in case of Rivian, the foam would it would catch flame for a certain time, but as soon as the flame is taken away, it would just extinguish on its own in few seconds itself. And that's why Rivian's that the foam material that they are using in Rivian is quite unique, and it can prevent thermal runaway or the spreading of fire through the battery cells. And lastly, we have the Hyundai Ioniq battery pack, in which pouch cells are being preferred. They are not using cylindrical cells, they are using pouch cells, and this is one battery module, and they are using number of battery modules. So this is their eGMP platform. So it will come in India soon. It is not currently being used in their Kuna, but they are going to use it in their new range of EVs, which is the Ioniq range. And they are again using the bottom plate cooling method in this. You can see the cooling channel is provided at the bottom of the battery pack, and it will absorb the heat from top, and it will keep the temperature of the battery cells minimum or at its working temperature. So yeah, that's it for today. And as I said earlier, I'm an author, an educator, and a content creator. So if you have any doubts, you can ask me right now.
So what is the optimum temperature in which the battery need to be operated?
So for lithium-ion batteries, it is kept between 50 degrees Celsius. If it goes beyond 50, the cells can work up to 60 degrees Celsius, but after 60 degrees Celsius, there are tendency for it to go into thermal runaway phase. So that's why for lithium-ion batteries, we keep it under 60. Basically, we keep it under 55 to 50 degrees Celsius because of to be safe, to be on the safer side. There are chances that in colder conditions, the lithium-ion battery packs would not perform as well as in warmer conditions. So like as Teslas are being sold all over the world, and there are colder regions like Ireland and Greenland, and where the Teslas are being used. So in that cases, the battery pack is being heated up using the heat of motor, and like the oil which is being used to cool down the motor, like their motors are oil cooled, that oil will actually give away its heat to the liquid which is being used to cool down the battery pack. So that liquid would heat up, and it will give the heat to the cells, so that the temperature of the cells would come to an optimum temperature, and they would work efficiently in colder regions as well.
Okay. And what temperature the thermal runaway for single battery will be started?
Whenever, like as soon as one cell goes up to 65 to 70 degrees Celsius, the thermal runaway will start occurring. And beyond that, like it can be controlled up till some point, but after that point, it will catch fire.
So, sir, I have one more doubt. What will be the initial stage of thermal runaway?
So initial stage would be, it will like the voltage level would deplete tremendously fast. The battery cell would discharge instantly because there is internal short circuit happening. So that is the initial condition. Simultaneously, there are temperature sensors mounted in the battery module, which will give information to the or the data to the BMS. So BMS will understand it, like if one battery cell is getting heated up, like it is getting heated up more compared to other cells, then it will start the protocol of thermal runaway before, like at that point.
Okay, sir.
Sir, I have a question that in India, we have many places like where the water gets logged.
Yeah.
So how safe it is to use these vehicles and the water get logged?
Yeah. So basically EVs, like the battery cells, like if we talk about the this safety parameters or the standardization methods for testing each and every battery module or battery pack, then AIS 156 covers it all. And in that cases, yes, we perform the water resistance and the waterproof test. And majority battery packs that are being used in our electric vehicles are waterproof and they don't allow water to come inside it. That's a different case when it comes to two-wheelers, because two-wheelers are using air cooling systems. So they will have some form of inlet for the air at the front end. So yeah, that is an issue, but still the connectors that we have that are being used, that would be covered with plastic or like this. You can see in this case. Yeah, this is the outer casing of the Tesla. So they will definitely be using such type of plastic. They would be covering the battery pack before housing it into a metal casing.
Okay, sir. Thank you so much.
So what is the difference between active cell balancing and passive cell balancing?
So in active cell balancing, the voltage, this is an easier animation that I've used. So yeah, you can see the center cell is getting like the voltage of this particular cell is dropping quickly compared to others. So the BMS would notice this, and what it will do, it will connect other cell with this one, and it will charge this cell to one voltage level so that each and every cell would come to a same voltage level. But when it comes to passive cell balancing, if one cell is being depleted fast, the BMS would just cut it off and allow other cells to come at the same voltage as this one. So
is it right, sir? Actually, in passive cell balancing, I think voltage when another cell is getting charged to another cell.
No,
because of the voltage difference between
that is in active cell balancing. That one cell would charge the other cell. The one which is being discharged quickly.
Are you sure? It is actually.
Yes, I'm pretty sure.
I think active cell balancing. Now the industry are using active cell balancing in the battery management system.
Yeah,
but nobody is doing passive cell balancing. So what is the reason? The industry,
one reason is being like because the safety of active cell balancing is pretty well than compared to passive cells. Like when it comes to passive cell balancing, it can lead to reduction of the lifespan of the cells.
How can, sir? How is it?
Because when it comes to like in this case, I'm just explaining in the basic way that it will cut off the battery cell. But in actual cases, whenever one battery cell has more voltage than other, it would connect it with an external resistance, and it will discharge more it will discharge some voltage from it, and it will allow it to come to the same voltage level as the other cells.
Okay, sir, but that means what is the time of which cell balancing is after charging or discharging? Which cell balancing is showing right cell balancing?
Basically, everyone uses active cell balancing. So even in case of discharging or charging, both cases it will be active cell balancing.
Okay,
sir. Hello.
Yeah.
Am I audible?
Yes, you are audible.
Yes, sir. What should be the DOD, depth of discharge for lithium ion?
So basically, to keep the lifespan of lithium ion batteries for a long duration, what the manufacturers do is they program the BMSs in such a way that whenever the vehicle is new, it will allow the battery to discharge up till 30%. But it will show the driver that it has been discharged up till 20%. So even in my cases, like we are using lithium-ion batteries in our cell phone. So basically what I do is I don't charge the battery pack till 100% because the BMS of our electronic devices, like our cell phones, are not programmed according to the BMSs of our cars. So in that case, you should, like in that case, only 80% of the battery cell is being charged, and you can just discharge it till 30%. So doing this, you can have a longer lifespan of lithium-ion batteries. So this is actively done by the BMSs. So whenever the car is new, it will charge up to 80% only. Although it will show that the battery charge is 100%, but it will be charged till 80%, and it will discharge it till 30%. But it will show till 20%. Now, as the vehicle would be running through various kilometers, as it gains some distance through time, let's say 100 kilometers or 200 kilometers, the BMS will start increasing the state of charge and the depth of discharge. So like it will allow the battery pack to be charged till 90% and discharge it till 25%. Then it will allow it to charge till 100%, and it will allow it to discharge till 20%. It will not go beyond 20% because after that, charging the battery cells would be actually difficult, and it would be difficult for the cells to hold their voltage after that.
When will you see the certificate, sir?
But the thing is, the range expectation would come down, right? If we charge and discharge between 80 and 30%.
Yes.
Then how to address that? What would be the problem?
Basically, when it comes to range, the calculation of range is done using the drive cycles, and they are using 1D methods, 1D simulation methods to calculate the range. And the drive cycles that are used for Indian conditions are the IDC or the NIDC. The IDC stands for Indian Drive Cycle and NIDC stands for New Indian Drive Cycle. So in that case, they will run the drive cycle for almost 5 to 6 times. And they will calculate according to that, like based on after running the EV in their 1D simulation model, they will calculate how much energy or how much state of charge is being remained in the battery pack, and they will accordingly calculate how much range it can provide. So the estimated range, which is being showcased in the brochures of many EVs, is calculated in this way. But whenever we drive it, of course, it is going to be down. So yeah.
Hello.
Yeah.
In the active cell balance, we are using only one BMS, na?
Yes.
Yes. So if I have in my battery pack 32 cells are there, and my 10 cells are 50% charges, my 10 cells are 60% charges, and other 10 cells are 20% charges. Then what will be the reading on my screen? Battery charging.
Your voice was not audible in between. Like, can you just repeat the voltage or the state of charge for each and every cell?
Actually, there are 30 cells in the battery pack, for example.
Okay.
Then my 10 cells are 80% charges, 10 cells are 90% charges, and 10 cells are 85% charges. Then what will be the reading on our screen?
So, like what will be showcased to the driver? So in this case, yes, the BMS would average it out and it will showcase 85%.
So just averages.
Yes.
Okay. But sir, sometimes we are seeing this problem in the vehicle where sometimes battery showing 100%, 89%, and suddenly the battery percentage is going down. So what will be the reason for that?
In that cases, yeah, definitely it can be the the cells would be faulty in that case because they will lose its voltage or lose their voltage pretty easily or pretty quickly. So the faulty cell is being used, so that will be the case.
If there is cell voltage down depth below the depth of the discharge,
yeah, it will.
It is a battery management system problem or cell problem?
Cell problem.
How can cell problem? So
yes.
why battery management system first BMS first showing the reading 100%, 89%, and then suddenly going decreases into the
because it will monitor as it is monitoring the voltage. It will see that the voltage is being depleted from one cell or number of cells pretty easily. So that's why the number that it is showcasing on the screen would drop down pretty quickly.
So
when will you see the certificate, sir?
Sorry? When will you receive the certificate?
Sorry?
Like, were you asking, like, are you asking when will you receive the certificate? Yeah, it will be after this session. I suppose the organizers will...
Excuse me?
Yes?
Yeah, this one important part of this battery is not only battery management system, the maintenance and as well as the disposal.
Yes, of course.
The disposal is there is a new concept that is coming up. I am not aware about very clearly that they are recycling this battery.
Yes.
Let us say, yeah, they are separating that and using it. Is it like, can you throw some light on that?
Yes, definitely. So, of course, as lithium is not that easily available for us. So, one of the ways of acquiring lithium is by recycling the older lithium-ion batteries. So this is actually a business model, and it is already been started in countries like America and UK. And although there are just 2 to 3 companies who are currently recycling the lithium-ion batteries. So these lithium-ion batteries would consist of batteries from, of course, EVs and other electronic devices like the drill machines or the cell phones or the laptops or power banks. So in that case, it will shred the material. It will take the entire battery pack. So like it is like an assembly line, but in this case, it will be a disassembling line. So they will give the they will put the entire battery module on the conveyor, and it will shred the battery cells into number of parts. So first and foremost, before placing that battery on that particular conveyor belt, it needs to be entirely discharged, and then they will shred it, and they have filtrations, like they will have separate filtration facilities, like to separate the heavy metal parts, they will use vibratory methods, and to separate the lithium part, they will use chemical method. And that's how they will recycle lithium and graphite and the other metals, and they will recycle them. And that particular lithium can again be used to create or to manufacture new cells. So this particular business model is not currently being worked on in India, but it is a good market. I suppose there is only 1 or 2 players in this particular business model. But yes, this is a good market, and this should come up in India as well.
Thank you. Do we get this, PPT and the recording?
Yeah, sure. I will share it with the organizers, and the organizers will provide it to you.
Right. Thank you. Thank you very much.
Good morning, sir. Good evening, sir.
Yeah, sir. Good evening.
This is Hemachandru, sir, and I want to know that which one is the best one for thermal withstand capability in order to maintain the battery thermal withstand capability. Hello.
Yeah. In case of lithium-ion battery, right?
Yes, sir.
So
sir, basically not in the industry, sir. Industry side, they are maintaining different methods. But if any students want to manufacture, do their own battery management system or a thermal, they have to maintain a thermal withstand capability in the battery. Which method they have to follow?
So at first I thought you were asking which battery chemistry of lithium-ion is less prone to catch thermal.
What I'm asking is, if any student want to make a battery and they wanted to maintain that thermal cooling system, battery cooling system.
Okay.
So, which one is the best one to have that cooling system in the battery?
Liquid cooling.
आकाश चोपड़ा joining अभिषेक नायर and me. आकाश चोपड़ा सबसे पहले तो आपके लिए खास तोहफा, उसके बाद हम आगे बात करेंगे.
So, is there any other doubt, or are we done with that?
No, sir. I want only that cooling system. Any students wanted to maintain or have maintained the battery cooling system. Which metal is better one to maintain any battery cooling system?
For battery cooling system, the method is, of course, liquid cooling is the best. If you're talking about the metal which is used in this particular heat absorbing or the channels, so it has to have good heat conductivity. That means copper has better heat conductivity compared to other metals. So that's why majorly it will be either made of copper, or they will be using aluminum in the cooling channels to absorb the heat from the cells.
Okay.
Sir, I have a question.
Yeah.
In the liquid cooling, it should be a direct cooling or indirect cooling?
Indirect cooling. Indirect cooling. In direct cooling, the cells would be immersed in the liquid, and it has its own issues because there are tendencies that the liquid can provide some, like the submersibility of the liquid will actually, like it will lift up the cells, and like the buoyancy will affect it and stuff, and it has short circuiting issues. So that is, it is a quite challenging method to do the liquid cooling method. So that's why it is an indirect cooling system.
Sir, in that, I want to ask you one more thing. That in the indirect cooling, can you suggest me a research area? For this, less work is done, and you can have a much tendency to work over there. Like that, any topic if you have.
Yeah, you can work on, see, you can do the CFD analysis of the cells with liquid cooling system and compare it with an experimental model. But of course, making a battery pack in your laboratory could be expensive because cells are not that cheap. And
Yeah, yes, sir.
simultaneously manufacturing such channels could be expensive as well, because you will be manufacturing it for just your particular battery module. So
Yes, of course.
if you want to get into this side, if you want to do like project, so then I would suggest, I would recommend this working on air cooling method, because it can be easily done. Like, to validate your CFD model, you will be able to create an experimental setup.
No, sir. I want to go with the model which will be very beneficial. As you have already said, air cooling is preferred for the two-wheelers, but I want to design for the four-wheelers. Then I would be working on the indirect liquid cooling only. But in that, what could I do new? That I'm asking.
If you are like, can I know your background? Like,
yeah, I'm a research scholar at NIT Goa, sir.
Okay, and your background is in electrical engineering or?
No, I'm from mechanical. I'm from a mechanical field, and I'm working as an assistant professor also somewhere.
Okay, amazing. So, in that case, like the reason I asked you this, because I would suggest to go into the chemistry of what the antifreeze or what the coolant is being used in liquid cooling system, which is at this point is ethyl glycol. But if you want, you can compare it with oil cooling system.
Okay.
So using oil as a cooling medium instead of ethyl glycol and water, and simultaneously there are other methods as well, like which is used in various laptops and phones. I don't remember its exact name, but they have this thermosiphon effect in their cooling system.
Okay.
So thermosiphon effect is like similar to PCM method. So in PCM, the phase will change of the cooling medium as it gets heated up, and it will siphon to another portion where it will release the heat and it will get solidified. But in thermosiphon, the liquid cooling method, in that case, let's say for example you are using water, then water will be evaporated and it will travel to another area where it will lose heat. So thermosiphon is actually a good idea to work on. Because, you don't need to provide any form of pump or any pressurized system to get that water to flow or that cooling medium to flow. So you're using basically pressure generation, like the pressure changes which is happening because of the phase changes.
Okay. I'll try to get certain research papers about that, and so that I'll get a clear idea what actually it is happening over there.
Sure.
Yeah. Okay, thank you so much, sir.
You're welcome.
Hello.
Yeah.
So what is the lifespan of a single cell in it?
So one lithium-ion cell can last for 500 cycles. Cycles as in 500 times it can be charged and discharged. This is an average value. Some cells can last slightly more than that. Some cells can last slightly less than that.
Okay, sir. Thank you.
Sir, you said battery boards are easily subjected to mechanical abuse. Then what is the advantages of? You said battery pouches are easily subjected to mechanical abuse, sir.
Yes.
So then what is the advantages of using battery pouches, sir?
Okay, that is a confusing question. You are asking for advantages?
So, sir, you said Hyundai is using that in upcoming car.
Yeah, okay. Oh, the pouch cell one.
Yeah, pouch cell.
Yeah. So in pouch cell, the pouches, each pouch is flexible in nature, and that's why you can house multiple pouch in one module. And their cells are like, they have developed their cells in such a way that they can be efficiently cooled. I still don't understand why they are not going for this, what we call it, the cylindrical cell. But I'm still getting into getting deeper into this subject as well. Like, I'm trying to find answers for the same question that you have asked right now. And but yeah, coming to the mechanical abuse point, they actually have structural rigidity provided in the chassis as well to prevent these battery packs from being from having penetration or mechanical penetration within them.
Okay, sir.
Yeah.
Sir, good evening.
Yeah, good evening, sir.
Sir, is there any open source software to simulate battery related?
For open source, I would usually recommend Simulink. But as Simulink is like for college professors and students, Simulink is available for free. But if you are a working professional in some other industry, then you need to purchase it. Other one is COMSOL. COMSOL is a good software to like simulate battery cell. And yeah, these are the two softwares that I'm aware of. I have used Simulink.
Also, I would like to add, we can also simulate on SimScale, which is an online platform.
Yes, thank you.
Okay, sir. SimScale, sir. Okay, sir.
Yes, SimScale. It is again from MathWorks.
MathWorks only, okay.
Yes.
SimScale and COMSOL, okay.
Yes.
Okay, sir. Thank you so much.
Sir, I have a question. Sir, is BMS algorithm completely related to battery designing, or is it generic for all? Like
no,
every
so if you're purchasing a battery pack from a manufacturer, then they will have the particular BMS already made for them, that particular battery pack. So that will be a common BMS for multiple battery packs for their standardized size. But when it comes to manufacturing your own battery pack, then you will have to create your own BMS. Of course, there will be BMS for certain configuration. Like for example, let's say if you're working on a 10S2P battery pack, then you can find 10S2P BMSs available in the market. But if your configuration is different, let's say 40S and 20B, then if the BMS is not available, you need to you need to manufacture your own BMS. You can also approach the battery manufacturing facilities, and they can manufacture a BMS for you for your particular configuration as well.
Is there any open source software where we can design our own BMS system?
So basically, for programming and coding, you can use MATLAB and Simulink. But again, in this case as well, COMSOL is highly preferable.
And just like one small doubt, is BMS algorithm and is related something to the BMS design only? Or are they both different?
BMS design is basically PCB design. So for designing the PCB, you should use EagleCAD. And for programming the algorithm, you should use MATLAB and Simulink. So basically, Simulink will have a particular program which you need to feed in for performing BMS this simulation. So in that particular block set, you will need to input your program.
Okay, thank you.
You're welcome. So I believe there are no more doubts, and thank you for being here. Thank you for also sharing your knowledge, because other than even I got to learn so much from you guys today. And thank you so much, ISI India, for allowing me to give this session to you guys.
Thank you, Purvang, for the session. It was a very wonderful session that you have delivered. Thank you, Purvang, for your valuable time. Yeah, Kashish, Kashish, want to say something?
Okay, hello listeners. Thanks for attending the webinar. I hope you all like the webinar and looking the exposure to enhance your learning and skills in the EV department. Okay, so here I would like to introduce ISI India pupils, which will help you enhance your skills.
Your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV Cadence EE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Okay, thanks everyone for watching this video patiently. Hope you guys have understood the products. So any of you wants to enroll in the course or interested in the course, kindly send us the inquiry through a QR code.
Dear learner, this QR code is only for the course inquiry. If you are interested in joining of any of the program of ISI India regarding the electric vehicle, so you can directly scan a QR code. Our team will contact you within 24 hours. Dear learner, like if you are interested in joining of any of the program of ISI India that you have shown in the video, so you can inquire now using our QR code. This QR code only for the course inquiry. The certificate link will be shared over the mail. So if you are interested in joining of the program of ISI India regarding the electric vehicle courses, so scan our QR code.
If anyone interested in this course inquiry, please scan this QR code.
How to download the certificate, sir?
Certificate will be shared on your mail